Next, we're going to look at how to find exact values and how we're going to create what we refer to as our unit circle. So the first thing we have to do is we're going to draw the diagonal of a square with a side length of 1 unit. Well, I'm going to draw out my square first. All these sides are going to be 1. And then when I do a diagonal that connects the two corners to each other, then I've created a right angle triangle where two of the legs are 1, and I can solve for what the hypotenuse is. Well, in this case, the hypotenuse is going to equal 1 squared plus 1 squared, or hypotenuse squared is going to be 2. Hypotenuse is going to be the square root of 2. Then I can write out what my ratios are going to be. Well, if this angle is 45 degrees, because these two sides are identical, this would also be 45 degrees. Then, looking from this angle, my opposite is going to be 1, and my hypotenuse is going to be root 2, which I can rationalize as root 2 over 2. It's going to be the same thing for cosine. My adjacent is 1, hypotenuse is root 2, and I get root 2 over 2. Tan, my opposite is 1, my adjacent is 1, that's just going to equal 1. And these are the 3 exact values for these ratios. Next, we're going to draw an equilateral triangle where every side is going to be 1. Then, if I know it's equilateral and all the sides are the same, that means that all the angles are going to be the same as well. They would all be 60 degrees. What I'm going to do is I'm going to create an altitude by splitting straight down from the top point to create these two identical right angle triangles where I have one angle that's 90, one angle that is 60, and then obviously the last angle would be 30 degrees. Now, the side lengths on the bottom are going to become 1/2 and 1/2. I just need to solve for my altitude. Well, if 1 squared is equal to 0.5 squared plus h squared, then my height, or altitude in this case, is going to equal 1 squared minus 0.5 squared, or 0.75, which is the same as 3 over 4. When I take the square root of the top and the bottom, that's going to be root 3 over 2. Now, using one of these right angle triangles, I can solve for my ratios. I can say that from 30, the opposite is going to be 1 over 2, divided by the hypotenuse, which is going to be 1. That's still just going to be 1 over 2. The adjacent, which is root 3 over 2, divided by the hypotenuse of 1, is still just going to be root 3 over 2. And for tan, I'm going to say that the opposite, 1 over 2, divided by the adjacent root 3 over 2, well, that would be the same as 1 over 2 times 2 over root 3. The 2's would cancel out, so that's just going to give me 1 over root 3 or root 3 over 3 when I rationalize it. Those are my three exact ratios. When I do it from the 60, well, suddenly the opposite's now going to be root 3 over 3, and the hypotenuse is going to be 1, which means that sine 60 is the same as cos 30. It's root 3 over 2. Cos 60 is going to be the same as sine 30, 1 over 2. And tan 60 is now going to become root 3 over 2 divided by 1 over 2, which just becomes root 3. If I'm using a unit circle, the radius or hypotenuse is always going to be 1 unit on the unit circle. So instead of r, I'm just going to call it 1. Which means that, in this case, sine of theta is going to be y over 1, or just y. Cos of theta is going to be x over 1, which would just be x, and tan is going to be y over x, which, as we've already seen, would be the same as sine of theta divided by cos of theta. So, as long as my r value is 1, x represents cos, and y represents sine. If I'm using the unit circle to determine sine of theta, cos of theta, and tan of theta for the angles of 0, 90, 180, and 270 degrees, well, if I start at 0, then I'm going to say that for 0, I'm going to have the point of 1 and 0, which means that sine is going to be 0 and cos is going to be 1. At 90, I'm going to have the point of 0 and 1, so sine is 1 and cos is 0. At 180, I have the point of negative 1 and 0, so sine is 0 and cos is negative 1. And at 270 degrees, it's going to be 0 and negative 1, so sine is negative 1 and cos is 0. When I'm solving for tan, well, it's always going to be sine over cos, so this would be 0 over 1, so it would just be 0. Here I'd have 1 over 0, gets an error, we call that undefined. For 180, 0 divided by negative 1 is still just 0. And for 270, negative 1 divided by 0 is still undefined. So, using what we've done in the last two pages, we can say that for the sine ratios, At 0, it's going to be 0. At 90, it's going to go up to 1. And then if I take a look at example 2, I can say that at 30, it's going to be 1 over 2. At 45, it's going to be root 2 over 2. And at 60, it's going to be root 3 over 2. The nice thing to remember in here is that the denominator is always 2 in these points in between, and the numerator just goes up, 1, 2, 3. Just remembering that the square root of 1 would just be 1. For cos, it works in the opposite direction that sine did. It starts at 1, it's going down to 0, the denominators are always 2 in between, but then it goes root 3, root 2, and then root 1 would just be 1. For tan, unfortunately, it is not as, it's not as simple as the other ones. You just have to divide them out or remember them. It starts at 0, then it goes to root 3 over 3, then to 1, then to root 3, then to undefined.